Hey everyone, super excited to launch this panel about how to put machine learning successfully in production. I want to welcome our panel speakers, Shiva Bisen, who's the lead data scientist at PackSafe, Emily Curtin, senior machine learning engineer at MailChimp, Eduardo Bonet, who's a staff full stack engineer at MLOps at GitLab, and last but not least, Niko Laskaris, our head of strategic projects here at Comet. A wonderfully talented panel that will be discussing how to put machine learning models successfully in production. They're very open to questions, so if you have anything you're interested about, please don't be shy and drop your questions in the chat. Thank you so much.
Hey everyone, we're so happy that you're joining us this year at Convergence 2022, a conference where we're seeing what it takes to actually generate value from machine learning and AI. Today we're going to be talking with some experts in the field about how to put ML successfully into production. I am sharing the virtual stage this morning with Shivika Bisen, who's lead data scientist at PackSafe, Eduardo Bonet, staff incubation engineer MLOps at GitLab, and Emily Curtin, senior machine learning engineer at MailChimp. And I thought before we dive into the conversation, and I hope that this is very conversational, I would love if each of you could just say a word about yourself, your background, what you're working on, and then maybe in the spirit of the topic of the day, you could share details about an interesting model that your team has put into production in the past year or so. And maybe, Emily, we can start with you.
Sure. Hey, y'all. I'm Emily Curtin. I'm from MailChimp / Intuit. That Intuit part's a recent thing. I'm a senior MLOps engineer, so I don't do modeling. I kind of work around the modeling space. An interesting model we've put in production recently as a team, one that I'm particularly proud of, not because of the modeling necessarily, is a model that does sentence splitting. So you input a sentence that's way too long and it gives you a suggestion about how you could split it up into two different sentences. So the modeling technology is probably very cool. I wouldn't know too much about that. But what I'm very proud of with that model is that that was put into production by one of our more junior data scientists who was able to navigate that whole process by themselves. So that's one that I'm particularly proud of for that reason.
That's amazing, and hopefully we get a chance to dig a bit deeper there in this conversation. Thank you so much, Emily. Eduardo, would you like to go next and share a bit about yourself?
Sure. I'm Eduardo. I work at GitLab as a staff incubation engineer on the incubation team, which is a weird team. I'm not working with ML models as well. I'm working with finding ways of improving MLOps experience within GitLab. But in the past, I was a machine learning engineer. I was a data scientist, more on the analytics side rather than the machine learning side, and among other things, including Android developer, backend, and front end. So one model that I'm very proud that I deployed in the past was actually almost 10 years back, was a model that helped students that took the exam on Brazil, the high school students that took the national exam in Brazil, predict their score based on a specific model that we had. That was a very nice project because I had to completely revamp the backend during the night because we didn't expect so much. That's how I learned that batch processing can be a lot more useful than real-time prediction. So yeah, lesson learned on the battle.
That's an excellent anecdote, and is foreshadowing something we're going to talk about a bit later about sort of what production means for different teams and different models. But I'd love to hear a bit more about that, Eduardo. And then finally, Shivika, would you like to go last?
Sure. Thanks, Niko. And hi, everyone. As you know, I'm Shivika, and I'm lead data scientist at PackSafe. So before I give intro about my role, PackSafe is a 3-year-old startup, and we provide real-time visibility for business-to-business shipments. It's like we are like operating system for cold chain shipments for Fortune 500 companies like pharma companies and food and beverage. So I build in my as a data scientist, I work with a lot of predictive modeling. I handle end-to-end project where I build predictive models for predicting adverse event that can occur during a shipment. So for example, we deal with a lot of cold chain shipments, right? So these items are like temperature sensitive, and one of the recent project that I worked on is also one of the like impactful project that went on to production. So this is like an advanced temperature predictive model where we predict temperature excursion happening before it actually happens, thus preventing any loss that happens to the temperature sensitive shipments. So yeah.
Fantastic, wonderful. Thank you for sharing that. And I'm very happy to hear. It sounds like we have sort of a wide range of perspectives. It sounds like Emily is focused on the infrastructure and the ML platform or the systems that are supporting the modeling exercises. It sounds like Eduardo, you've done a bit of both. And Shivika, you're in some ways a hands-on data scientist building models. So we'll have lots of different perspectives on this topic. So as we dive in, I actually want to sort of take a step away from production because I think, as all three of you know, good offline R&D practices around model evaluation and experimentation are often critical to producing models that can perform well in production. And so to start, maybe Shivika, I'll flip it right back to you. How does your team think about managing offline R&D or the model development process prior to putting a model to work? And I know that we'll talk about what that looks like a little bit later on.
Sure, yeah. I'm happy to talk about because this is one thing that I really enjoy in the team because we deal with a lot of pioneer models and we have to do a lot of research, industrial research. So I can explain it in a flow manner. So we begin with like a research phase where we do a lot of thinking on what is that we are given with, like what would the input data would look like and what is the output that we want, and then all the constraints that are there to that problem. So basically you can say clarifying the problem statement, and we come up with a lot of constraint that could be there over the flow of production. So thinking all of this beforehand is very useful before we dive deep into like research. After we have like clarified all of this aspects, we then do a lot of research, paper reading. We also reach out to researchers who are already working on certain problems that interests us. So we get to know from their experience how is the implementation, and is that something that they would like to suggest us. Once that is done, we also maintain like a documentation early on. I think this documentation practice is really important because if we want to iterate over the research offline, then we can always go back and see where we came from, and all of this process takes time. So we maintain something like PRFAQ document where we have like all the questions, extensive list of questions that can come up from the customer point and also the internal team points. And once all of that is done, we then move on to data collection phase where we collect data relevant to our model, then do a lot of EDA, exploratory data analysis on that. This phase also helps us in building features for our model. So all of these are really helpful for the next phase, which is like model building. And we usually begin with model building with deciding on the baseline model that we want to do better, and then we also decide on a metric that we want to compare our model against the baseline. Once we have decided that, we build feature engines, and then compare at least top 3 models that are competitive to our model that we are planning to go with. And then that's how we get the trade-off for our own model. And once we decide on what model we want to go with in our R&D phase, then we also do some of model explanation, like trying to understand, is this model trustworthy? And then we use a lot of model explanation tools like Lime and SHAP to understand what's happening inside the model. And I would say, yeah, once that's done, I guess we do a lot of model evaluation, and that's about it.
Amazing. Yeah, it's a very extensive process. I'd be curious. I have just one follow-up question, which is how much of the system and process that you just described, how much of that was built having learned the hard way or making mistakes in the early days, or was that sort of always there?
Yeah, it's always there. The learning process is always there, and with every model, I think we learn how we can avoid that in different, like the other model. But every model is different also, so it's not always a perfect road ahead that everyone has. They'll have a basic idea what they can avoid on and what they can adopt, like the best practices, but there would still be some surprises on the way that we see.
Of course. Yeah, I'd love. Eduardo, does this process sound similar to you? I'd love to hear your answer on this, and perhaps from your perspective, I'd love to hear how your experience as an applied machine learning practitioner has impacted how you think about building systems to support data scientists now.
Yeah. So on the previous company that I worked for, we were 3 machine learning engineers. It was a small startup, which was a branch of a larger company. It was focused on delivering innovation within the company. What we would do on the research phase is that first we would have always conversations with internal users and customers of our use case. So we would do user research ourselves. And second, most of the time, all of the testing and exploration would happen in monthly hackathons. So monthly hackathons, 2 or 3 days, were the time we would just go and be crazy and, I don't know, take whatever data set and come up with an idea, and then we would hold a small presentation afterwards. This is how we would come up with the ideas for publishing. Outside of that, we will be building things that would try to deliver value. And one of the things for me, after implementing some stuff with ML, is not to use ML in the first place. Always try to use very stupid if-else heuristics or whatever hard-coded things just to get user validation of the case that I've been working on, making sure that that thing actually matters. And later on, that stupid thing will become the baseline that we'll be trying to improve upon. So if somebody asks us, okay, you have to implement a machine learning model, just implement anything else within a sklearn interface, like it's just a predict and it's anything else. But it's one way to make faster to iterate, because then you're already working on the front end, you're already working on the back end, and sometimes the machine learning can take a lot more time to arrive.
Yeah, so, I think that's an excellent insight. Something we see all the time. You touched on a couple interesting points. One, always start with a simple model or a simpler model, if possible. And two, make sure that things are closely tied to what are actually going to drive business value, so teams don't spend months building some sophisticated model that does something that actually won't, be impactful ultimately. Now that you're at GitLab, Eduardo, I'm curious, as you've sort of built systems and processes to support the data scientists, what are some of like the biggest pain points that you saw the team at GitLab experiencing, specifically with sort of the offline R&D aspects of model building?
Yeah. So the thing about the folks that I've been speaking to and other customers is that you have machine learning leaders, which is Google, which is Facebook, which are the companies that will push machine learning forward. That's not the majority of the companies. Majority of the companies are now going from SAP into some kind of data warehouse-ish setup that now they are trying to extract value from the data. So they don't need the top of the market algorithm. They don't need to develop their own solutions. They can linear models for them is already something that can drive a lot of value. So the use cases are very different. The demand for hardware is very different. The ways that we are working, these companies are still trying to build their culture. So the way that you implement the tool is also a way that you drive the culture within data science for those companies. So ways of making sure that, for me, my goal within GitLab, my vision within GitLab is make the GitLab the best, make GitLab a tool that data science love to use. Because when I was working before as a data scientist, more on the analytics side, there wasn't a lot of, Git didn't bring a lot of value to the data scientist. There was the need for some place to store your notebooks. There was a need for a place to collaborate, but Git doesn't play well with those. So this is what I'm working on with GitLab, is making sure that data science and Git work well together, that the CI works well with Git, with data science. So what are the use cases where we can improve upon? So yeah, that's how it kind of like, and trying to guide a healthy culture within these new teams that are being formed.
That's fascinating. Yeah, Emily, does that resonate with you at all? I know that you're focused, on building tools to support a team. What's been your experience of helping your team of researchers in this regard?
Yeah. So fascinating to listen to both y'all talk about your experiences. So before I wrap around to answering your question, what I loved about what Shivika was talking about is everything you listed was um, like customer requirements, research, mathematics, statistical fallacies. It was all that kind of stuff. Um, and then turning to Eduardo talking about you know, as software engineers, we love version control, but Git may not be driving value for these people who are focused on statistics, customer requirements. Some The data science space tends, they have a very tough job outside of the whole ecosystem of software engineering. So I think definitely what Eduardo was talking about bringing a culture of software engineering to data science um, through tools that actually deliver value and aren't just a hindrance. Um, that's definitely what my team is currently focused on. We kind of think about the data science life cycle. There's a million charts about this, but you can kind of think about it as like a tight inner loop of experimentation and then an outer loop of production iteration. Um, so in terms of ML ops maturity, we're definitely further ahead on different points of those. And right now, our experimentation loop is actually the one that needs a lot more attention. Um, so yeah, that's where my team has been focused currently around how we can bring the best practices of DevOps and of software engineering to folks who may or may not have a software engineering background and certainly have a lot on their minds without all these other systems concerns. So, does that answer your question, or did I kind of
Yeah,
miss it?
no, it's an excellent answer, and I'm very curious to hear. It sounds like I think your experience is something we see a lot working with our sort of friends of Comet or customers of Comet, that teams feel sort of comparatively more or less advanced in different stages of the
Mhm.
the, the ML life cycle, both from a modeling perspective or from like a system and process perspective. So when you say that um, the your area of focus is maybe more on that inner experimentation loop, like how is that manifesting for the team? What are the pain points that either you're seeing or the researchers are
Mhm.
experiencing, and yeah.
Sure. Yeah. I guess a quick corollary is that part of why we're not focusing on the production loop right now is because some of our deployment infrastructure is actually pretty slick. But experimentation wise, one problem that's peculiar to our setup and may not transcend to other businesses or might, um, traditionally a lot of MailChimp's infrastructure has been on colo servers. And that has to do with the fact that our core business is email. Email relies on IP reputations and all this other kind of email specific stuff. So that side of it has always needed to be on colo and will probably never leave colo. But as we're making a move as a company to migrate to the cloud, and data science has been way out in front of the rest of the company in terms of pushing that. However, we've been relying on uh, developer tools that are still hosted in Colo. So it's up to data scientists to do this crazy bouncing between their development environment on the Jupyter notebook in the cloud, where it's co-located with their, you know, their data lake, which is another part that we're doing good on the data lake. um, so you've got your Jupyter notebook on the cloud, which is being version controlled in Colo, which has to bounce to a data scientist's laptop in order to do that handshake, which also means a lot of transference of artifacts and um yeah, there's a lot of very painful low hanging fruit here just around the mechanics of the day-to-day work of writing code and collaborating on code. Um, Beyond that, there's a lot more interesting questions we're looking to tackle around experiment tracking, data versioning, uh, really getting some more advanced tools into our training cycle and retraining by that. But we absolutely have to tackle these low hanging fruits first because um, if you can't commit your code and you and as Eduardo said, if that's not bringing any value to you, um, then going through this super painful version control process is just a hindrance.
Shivika, Eduardo, does that resonate with either of you, what Emily's talking about?
Yes, completely.
Everybody has faced the pain of getting your Spark cluster stuck somewhere after a 2-hour long query. Yeah, I remember that.
So it sounds like there's some commonality of experience here. Well, fascinating about offline R&D, and I want to be sensitive to time and make sure we spend some time talking about getting models into production, since that's ostensibly what we're supposed to be talking about. But this is a very fun conversation itself. And to switch gears and start talking about production, I actually want to start with you, Eduardo, based on something you mentioned when you were talking about your background and this model you built. You built, for predicting test scores and discovering the merits of batch. I think that there's a tendency we see when you hear about ML production. You oftentimes jump right to real-time inference and a customer-facing app and all of this stuff. But in reality, production can mean like many different things for different teams or different models. Batch predictions run hourly, daily, weekly, monthly. It can be real-time inference. So Eduardo, maybe talk a bit about what production has looked like either in your past as a researcher or at GitLab now, and then I would love to hear you talk a bit about the merits of batch as opposed to real time.
Yeah, I'm very practical on this. Production is not about tech. Production is about being consumed either for decision making or for prediction for the user. It's when it reaches, it's when it's consumed outside. It's not about whether it's in a good tech or not, whether it's batch or not, whether it's in a CI/CD or not. Is it being consumed by a user? That user can be a dashboard that is informing business. That user can be a actual user on the front end, consuming this through a streaming prediction process. This user can be another machine learning model within the company. This user can be a lot of things. But the point is it being used? That's production. Now, it might be that it's not in good quality for production. That doesn't change the fact that it's in production. So that specific on the batch was quite an insane one, because the way that thing, the first model that I built was built, would scare a lot of machine learning engineers away. It was a Go backend simple API that would call, and the model was in R, so I would call the model as a subprocess within the yeah, exactly. It was not nice. I'm not proud of it, of the tech in itself, but it was in production. It delivered value. It made something new, and at that point, the users don't really care. Well, if it was not, when it was not working, users cared. That was when it was running on trying to predict live. When I switched to batch, okay, they took 1 day to process, and you would update every day. It was fine. Users didn't care. The fact that they had it in the beginning was good enough for them. And this can change from model to model, because some use cases require that you have fast prediction times, and being in production would mean match those use case of fast prediction times. But that will depend on the use case, not on the tech. The use case is what drives the tech in this case.
Emily, I see you've been nodding along to most of what Eduardo has said. I'd love to hear your thoughts.
Oh, 100,000% that just because it's in production doesn't mean it's production worthy, but it is in production. Yes, and that choosing real-time predictions or choosing batch, like it's a question for the use case, certainly. And in some instances has to be hedged against the capabilities of the actual model you're working with. So when we're looking at putting a service in production, one of the first decision points, there's a major decision point of how is this going to be consumed? What are the requirements there? Beyond that, it's how fast is this model's response? Because there are some models that are quick. There are some models that are extremely computationally heavy. Some of which can be sped up through hardware. Some of which cannot, just through if you've got a recursive algorithm of some sort, you may not be able to do anything about that with hardware. So that is also a decision point in our process about are we going to try to serve this live, or are we going to pre-build the results and serve the results in a way that's efficient for the response. Particularly in our case, when we're talking about a prediction that ultimately serves an end user and not just another internal process, if our predictions are slow, that puts a huge burden on the front end team to build the experience around that slow prediction. So a user's not just sitting there getting nothing while the model is churning way off in the back end somewhere.
Fascinating. And Shivika, what about you?
I totally agree with Emily. The use case decides what we want to go with, whether it's a batch learning or online inference. So for our use case, we deal with real-time visibility. So we have no option but to go with like online inference. And then that's why we have to do a lot of selection, like which model to select, which will do well for our case for online inference. So I would say that lucky for us that we don't even, in some cases, especially like the example that I gave, if you want to predict the temperature excursion of a shipment, every shipment have its own trend, and there are lots of shipments going globally. So you can't really, and you want to give them a real-time visibility, so you have to, know that not all of the data would be important for the model. The later you go down the data, it won't be relevant to the recent prediction. So that's a good thing, and that's why we do a lot of testing with just the sliding, getting the recent data and training recent data on our model and then predicting, and it works fine for us. So yeah, depends on the use case.
Got it. Yeah. And I suppose one thing that does not depend on the use case, nor whether it's online inference or or batch, is that things start to change once a model hits production, right? You have new data, you have data drift, you have things falling apart. What's a couple of, maybe Emily, back to you. What are some, I guess it's like a two-part question. One, sort of, how does your team think about building retraining pipelines for models in production, or helping your team think about models as living, evolving artifacts as opposed to a static H5 or pickle file or something? And maybe we can just start there and we'll dig in deeper.
I don't know what you're talking about. Pandemics never happen. Data never changes. So I think this is a place where we are building maturity. So we have some models that are way out ahead of the rest in terms of, we have some models that they're doing live prediction. Those predictions are going into a feedback table that can be looked at by data scientists, by other processes down the road to see about data drift and about response drift. Some of our projects then take that and retrain it and have this whole automated system to compare the results of the newly retrained model and make a decision about whether to push that to production through like an automated pull request kind of process. And some of our models do not have that. So it's definitely an area of maturity for us. One thing I have learned a lot from my data scientists is how to be statistically careful about retraining and how to do a good comparison of, is this model better than the last one, or is this some fallacy in the data or other statistical trickiness? Oftentimes that's not a simple question, so it definitely takes an expert in the loop there to kind of design that decision algorithm when it comes to retraining.
Shivika, what's your experience? What's your team's approach to sort of continuous learning or retraining with models in production?
Similar to what Emily said, I think, usually whatever model retraining we'll do, it's like an automated one where we, for example, say AWS SageMaker, you can just divert the traffic to 80% of the traffic to the old model and then 20% to the new model, more like an A/B testing, right? So just and then decide on a metric that you want to compare each model on to make sure that your new model has been performing well compared to whatever changes that happened, like data or concept drift that happened. Is your new model able to handle that? And I think all of this comes and brings us to the whole idea of versioning also, right? Like there are a lot of versions that we build, and that's why GitLab and all of these interfaces are really helpful for us to do this retraining and experimenting, getting comparing the different versions.
Eduardo, how do you think about this?
Yeah, so I mentioned this somewhere else, but Shivika mentioned A/B testing. I think this is such a good tool for this. I say this because, I worked at Booking.com before for a few years within their A/B testing framework for a while as well. And who heard of Booking, of course, remembers hotels, but they all within the tech, they also remembered because they have a very, very strong A/B testing culture within the company. It's across everything, not only for data scientists, it's for all types of roles. And I feel that a company that has this kind of culture can process machine learning a lot easier. Any PM, any developer knows how to look at the metrics of machine learning model and challenge them without even knowing the machine learning, because it's a change, and you're challenging the metrics, you're challenging the use case, you're challenging how the use case affects the metrics, right? And that helps a lot. It doesn't mean that it's mandatory to have an A/B test framework, but having the framework and the culture also means that you probably have your data already your data culture in a good shape as well. So once you have that, it becomes easier to do machine learning. It becomes easier to put a model in production and understand within business metrics, because in the end, model metrics don't matter. What matter, well, for some cases here, but what we're talking about here is production, is for the user value. It's business metrics that matter. It's not the map 5 or a map at K or whatnot. It's, I don't know, revenue, not revenue, but a user experience metric, I would call. So yeah, having that set up already helps a lot for being challenging in itself and challenging within your own models.
Yeah, that's an excellent point. We're seeing A/B testing pop up more and more as I think more and more teams get more and more models into production. That said, I think we hear a lot about data drift and about the issues around data once a model hits production. We hear a lot about A/B testing, but it also feels like every team has very unique and sort of specific pain points that emerge as they put their models into production. So maybe, Emily, to start with you, sort of an open-ended question, but if you could sort of wave a magic wand and sort of completely remove a pain point that your team sees in production with their models today, what might that pain point be that you would love to solve?
I'm gonna need to reach beyond my immediate answer, because my immediate answer is, well, the things I'm working on, of course. I would love a magic wand to solve the pain points that we've already identified, being that kind of low-hanging developer tooling stuff that we've talked about. I actually think my answer here might be a people answer, and might build on exactly what Eduardo was talking about with culture and incentives, and how that trickles down into practice of machine learning and putting these models into production. Um, it's I love that point you made about uh, when the product managers have this culture of A/B testing and this culture of challenging the results, even in if they may not be a machine learning expert, but they can still challenge the end results at a consumer level. Um, that has major trickle down effects, exactly like you're talking about. That produces incentive for uh, better better data versioning, better versioning of all sorts. There's a lot of stuff to version in our space. Um, Better testing, better reproducibility, all that kind of stuff. That's yeah, that's definitely an insight I'm going to take away, is that if your product managers can carry a lot of cultural weight and produce a lot of incentives that trickle down.
That's an awesome answer, sort of like a people culture shift as opposed to
Mhm.
the other stuff we've been talking about. Eduardo, what's your take? What's something you'd love to just wave a magic wand away?
Please solve MLOps in general. Just like poof, done. No, I think for me it's also a people problem. Like all tech problem are people problem. Very rarely you actually have a tech problem with it, which is a tech problem. It's mostly people problem. But is just going beyond the hype of machine learning being a solution looking for a problem, and rather bringing this more of understanding what can be done, what should be done, when should we apply even look into machine learning or not. I think right now the use cases are very siloed into the experts, the people who know machine learning, and they are looking for how to apply machine learning. But when you change that perspective and the ideas come from all sides of the business, all sides of people interacting with the customers, and they understand, okay, this could be something that I could talk to that person that knows how to implement it, and then we can deliver value in a different way that we could never think. We're very limited into our vision on what we can see. And having these ideas coming from the other side, it's very helpful. Right now, machine learning is a scary word. At the same time, it's scary. At the same time, it's very useful because it automatically fivefold the valuation of a company. But once it goes away from this magic, I would say it becomes a lot more helpful. The conversations become a lot more helpful. You're not discussing anymore like the magic one. It's almost like discussing, okay, which database are we going to use? Sometimes not even worth it discuss it. We can just use something else, but it becomes a different beast, I would say.
Yeah, fascinating. Shivika, what's your perspective?
I think for me, if you'll ask what could be the magic wand, I would say high quality training data pipeline tool. Because for my use case, especially that I'm seeing for online inference, it's only so much you can do with the model. You need right data, high quality training data on which your model can train on, because you can't really use very complex models, and also you can't really spend time on tuning the model, because it's like on time learning, like real time learning. And that's why latency is a very like a challenge for us, like in online inference. And we want to make sure that in couple of seconds we have to do learning as well as prediction. So that's why the training data has to be good quality, that would give us good features that would converge with our model. So I would say that magic wand would be like an airtight data pipeline plus a retraining model pipeline, which would ingest all the high quality data and then retrain the data and benchmark itself, and then your deployment is done. So yeah.
I like the sound of this hypothetical world. We're just three magic wand waves away from a really nice world.
And we can all just go to the beach and enjoy the time.
Yeah, exactly. Let's just get there now. Well, I want to be sensitive. I know we're going to wrap up here in a couple of minutes. So my final question is sort of on the same vein, but Emily, we'll start with you. What's one prediction or hope you have for the way you and your team are sort of managing ML in production a year from now or 18 months from now? That's different from the way you're doing it right today.
Yeah. The dream, the hope is that data scientists are able to go from concept to production worthy model seamlessly without having to deal with artifact shifting or Python dependency reconciliation or Kubernetes errors or all that stuff that will always be there. So this is always kind of a North Star goal. I do predict for us that we are going to make significant progress on the reproducibility of model training and thus the reproducibility of retraining, and wrapping that into more of our CI/CD and kind of GitOps practices.
Shivika, what about you? What's a prediction for your team?
I think I can see, since we use a lot of time series data, so I can see my team using libraries to that can help simulate the real time incoming data while we are doing the model evaluation. So that is something presently we do we build code by ourselves and do it, but I think we can use some libraries to do so. And for serving, I think using hosted notebooks that can help expose the API also. So in a way, it would I think it would cut down on the time between development and deployment. So yeah.
Excellent answer. Yeah, and Eduardo, final word. What's a prediction you have for the next year or two?
I see the I don't know, early parts of machine learning moving more and more towards software engineers. This has already been happening for a while. The whole machine learning engineer comes from this as well, but more and more towards machine learning engineers, towards software engineers, less machine learning engineers, more MLOps engineers coming up. So central team platform, and the reduction of reducing the size of the central data science / machine learning team within orgs, and more distributed across different teams. So instead of having one team with, I don't know, 10, 20 data scientists, you're going to have them spread out across the software engineers will do a lot of this work already of implementing simple the models, because they are closer to the use case. We have a lot of this agency style model within companies itself, where you have the central data team, where you make requirements, data team comes with a model. And I think this will be a lot more distributed. The easier it becomes to create machine learning models, the faster this will happen. And this has been already, if you look at the industry in the last 5, 6, 8 years, this is already something that has been happening. So it's not really a prediction, it's more like continuation.
Well, I hope for my sake and all of yours that all of your predictions come true and the magic wands are waved. Unfortunately, that's all the time we had. So to the audience, thank you all so much for attending. Eduardo, Shivika, and Emily, thank you all for a fantastic conversation. I hope you had as much fun as I did. This has been a conversation around how to put ML successfully into production. And we hope to see you all sometime soon.
Thank you, Niko. It was a pleasure to be part of this, and I think this was a great initiative by you guys. Thanks for bringing us together.
Yeah, I had a lot of fun talking with y'all and got some great insights. So may all your models never drift.
Thanks. It was fun.
Thank you all.